In last video, we studied about the vector addition. Now in this video, we will learn about multiplication of vector. Multiplication of the vector can be done two ways. First is the multiplication of the two vector in which we get scalar output, and another is in which we will get vector output. Means there are two methods of multiplication. In one method we are getting scalar output, and another method we are getting vector output. To go into the detail, let us first understand some concept. Some little more concept we will understand. So in last lecture you understand that there are some unit vectors I cap, j cap and k cap are unit vectors along positive x, y and z axis respectively. That we studied in last lecture. Okay. So here in this chapter, we will go into the depth of that. This I, j and k, these are the three unit vectors and they are sufficient to give the direction, any direction in the space. Now, these three are along the x, y and z axis. As the x, y and z axis are mutually perpendicular, these direction, these unit vectors are also mutually perpendicular. So second thing that we must notice that I, j and k are mutually perpendicular to each other. Perpendicular to each other. Okay. And one more thing that we will notice here, that the any point can be positioned in a space with its x, y and z coordinate. So to position a point in a space, we need x, y and z coordinate. Three coordinates are required. Using these three coordinates, we can write the position vector of that point. Suppose, how to write the position vector? So position vector of a point, say we are having the cube as x, y and z. Then the position vector of this point can be written as small q x I cap, y j cap and z k cap. Is that clear? So this is there is one more thing to understand after this. The magnitude of vector q. The magnitude means distance of the point q from the origin. So the magnitude of vector q can be written as mod of q, or it can be simply written as q without arrow, and it will be given as root of x square plus y square plus z square. That means it is the coefficient of I. This one is the coefficient of j and this one is the coefficient of k. So whatever the number you will have as a coefficient of I, j, k will be squared and added, and then the square root of that will be taken. Okay. So here we understood some concept regarding the unit vectors and the position vector. Let us see what are that conditions in which you need to take multiplication so that you will get scalar as a result. Remember the work done. What is the formula for the work done? Work done is equal to force into displacement, isn't it? Now you see, the force is vector, displacement is a vector, but the work done is not a vector. Work done is not a vector. So I need work done as a product of force, which is vector, and the product of displacement, which is also vector. So the product of force and the displacement should be obtained as a scalar, because work done we know is a scalar. So here, after multiplication of the vectors, we are getting scalar. Now one more example of the torque. Okay, at this early stage of your science study, you might not be aware about the torque, but let me tell you what is torque. When you are opening the door, suppose these are hinges, over the hinges the door is hanging. Now you are opening the door. Now what you are doing? You are actually turning the door. This turning effect, the couple of force which turns this is called as torque. So if these are the hinges over which the door is hinged, now if you want to move this, the door will move about this axis. Is that clear? The door will move about this axis. Suppose the force is applied here, so this is here, and the distance of the force from point of force from the axis of rotation is suppose r, then r and this f. The product of the r and the f gives torque. Torque means perpendicular distance. See, the distance has a, this perpendicular distance means in a particular direction. You cannot take this, you cannot take this, you have to take this perpendicular. So the perpendicular distance into force. In this case, both are vector. That is, this r is a vector, this f is a vector, and torque is also vector. That means there are conditions in physics where, for some reason, for some purpose, we need to multiply the vectors to get scalar, as we done in case of work done. And there are some other certain conditions in which you will need to take the multiplication so that you will get vector, as we have done in this case. We have said that yes, there are requirements. Then there should be the corresponding definition with that. You will see how the definitions are formed. So first of all, I will write definition of scalar product. So for scalar product, the magnitude of scalar product is given by the product of the magnitude of two vectors and angle between them, and angle between and the cosine of the angle between them, cosine of angle between them. Is that clear? That means if you are going to multiply vector A and vector B, so that you are getting the scalar, in that case the product of A and B is given as A dot B into cos theta. Here you see the vector needs arrow over the head, then it becomes vector. We call it vector. If you remove the overhead arrow, you will get the magnitude alone, means direction is not considered. Here also, vector A dot vector B is equal to A dot B cos theta, means A is magnitude of vector A and B is magnitude of vector B. Is that clear to you? Now, here this kind of product, scalar product, is denoted by this dot sign. It is denoted by dot, and therefore it is also called as dot product. It is also called as it is denoted by dot, it is called as dot product. Is that clear to you? Now let us see what is the vector product. For a vector product, now here one thing is very important to notice, that the magnitude of the scalar product is given by the product of the magnitude of two vectors and the cosine of the angle between them. Here I started with the magnitude of the dot product or a scalar product, magnitude. But here, do we need the direction? No, because we know that we have done the multiplication the way it will not give us direction. It will give us only the magnitude. Means in this kind of multiplication, we do not have direction. So, very interesting thing, that you will do the multiplication of the two vectors and you will get scalar, not the vector. But here, in a vector product, we will get vector, and therefore here the word magnitude has a certain meaning. यहाँ तो कुछ खास meaning नहीं था, but here it will have a certain meaning. So we will write here the magnitude of vector product of two vector is given by the product of magnitude of two vectors and the sine of the angle between them. Is that clear? Now let that two vectors are A and B. Then you will write A cross B is equal to, now here I told you earlier that the magnitude here has certain meaning, because this time we are doing the vector product. We are multiplying the two vectors to get vector again. So in this definition, I am talking about the magnitude alone. I need to consider the direction sometime later. So here A cross B will have the magnitude equal to A dot B sine theta. A dot B sine theta. As this multiplication is shown by this cross sign, as it is shown by the cross sign, vector product is also called as cross product. Vector product is also called as cross product. Why? Because it is denoted by cross, and the scalar product is called as dot product because it is denoted by dot. Is that clear to you? Okay. Now let us see the properties of scalar product first, and then I will tell you from the vector product. Now I will write the properties of scalar product here. Properties of scalar product. next property is A dot B is equal to A B cos theta. Means its definition is its first property. Is that clear? And the second thing from this definition can be inferred, like if theta is 90 degree, then the product will become 0, like here. So perpendicular vector have 0 dot product. Perpendicular vectors have 0 dot product, that is A dot B is equal to A B cos of 90, that is 0. The second thing is that we can say that if I, J and K are going to be multiplied here, like this. If I multiply I with the I, if I multiply J with the J, and if I multiply K with the K, what will I get? As the angle with the self, suppose this is I and again this is I. So angle with the self is 0. Suppose these are two things, they are on each other, and if they are on each other, then there is no angle between them. So there is no angle between I, J, and K. That is angle is 0. See, magnitude of this all is 1. Magnitude of I is 1, J is 1 and K is 1 because they are unit vector. So their magnitude can be written as 1 into cos of 0, that is again 1. So this is the third property where you will see that a self dot product of a unit vector is unit. Self dot product of a unit vector is unit. And the fourth property is, in case we take the product between I and J, J and K, K and I, is they are not, they all are mutually perpendicular to each other, and here you see perpendicular vectors are 0 dots product, and therefore here I can write, if you are writing I into J or J into K or K dot I, the dot product of this is always equal to 0. Remember, A dot B is equal to B dot A. Therefore, J I, K J and I K does not have different meaning. So in that case also it will be 0. And this plus that A bata. Okay. And then let us see this product, dot product, in its pure mathematical form. So here I will take two vectors in the form of their x, y, z and I, j, k. Okay. So there are two vectors. Let me write here in a good area. I will need to big area for that. Let vector A is denoted by ax I, ay j and aj k. Remember, this is a x y z, but these x y z are associated with the point q. Therefore, qx, qy and qz will be the label for them. We will label them. Otherwise, this is the x coordinate, this is the y coordinate, this is the z coordinate. Similarly, the D can have the bx I, by j and bj k. Now we are having these two, and let us multiply them using this rule. So then you are getting A dot B is equal to, in first bracket write the AXI plus AYB, AYJ plus AJK, and in second bracket you write bxi dyj and bzk. I think I should mark here like this. Okay. Now here you will multiply the first term with all these three terms, then you will multiply the second term with all these three terms, and you will multiply the third term with all these three terms. So that will go on as normally we do in our algebra. So A dot B is equal to first Ax, then this Bx and I dot I plus then Ax and By then I dot j. Is that clear? And then Ax will be multiplied with this Bz. Ax have the I and Bz as k. So I dot k plus Ay j Ay and Bx. This is j and this is I. J dot I plus then Ay By j dot j plus then Ay Bz j dot k. And then again the third one Aj Bx k I plus Az By k j plus Az B j k dot k. Now you see in this all using this property, which one? This I j j k k. So I j j and k k will become 1. Why? I j j k and k I, this part, this and this will become 0. This will become 0. No, sorry, this is not this one. This one becomes 0. So finally, what you will get? You will get A dot B is equal to Ax Bx, Ay By and Az Bz. This is now become a mathematical formula to take the dot product. So using this formula you can take the dot product. Example here. Let point A is 2, 3 and 1 and point B is 4, 3, 1. Then you can write vector A as 2i plus 3j plus k, and here you can write vector B is equal to 4i plus 3j plus k. Now you can say that A dot B is equal to, what is here, the coefficient of the I multiplied with the coefficient of the I. So here the coefficient of I is 2 and here the coefficient of I is 4. So 2 into 4 plus, then here the coefficient of j and coefficient of j, 3 and 3. So 3 into 3 plus, then here the coefficient of k is 1. If it is not given, it is 1. Here also it is 1. So 1 into 1, 1. So what you are getting? It is 4, 4, 16 plus 9 plus 1. So it becomes 26. Is that clear to you? So this is how we can solve using this formula. Now these were the properties of scalar product. Now there are one more thing that I need to tell you that will help us in understanding some more concepts while solving the physical problems. See, our formula is A dot B is equal to AB cos theta. Then what this is B cos theta, or if you can write B into A cos theta, then what is this? A cos theta. So that is then become the last property. तो property क्या होगी? See here, the B cos theta is the component of B, vector B along vector A, or you can write directly vector A in a symbol form like this. The similar way, you can say the A cos theta is the component of A, vector A along vector B. You can write that here. Similarly, A cos theta is the component of A, vector A along vector B. So you have seen how these properties will help us to understand the values of some vector quantities in certain direction. Suppose you need to move this box in this direction. You need to move the box in this direction. In this direction you need to move the box, but you are applying the force in this direction. You are applying the force in this direction. Now, actually your all force will not work in this direction. Only, suppose this is the F, then only the F cos theta will work in this direction. If this is F, then F cos theta will work in this direction. Suppose cos theta is 60. Suppose this is 60. Then this becomes F cos 60. Cos 60 is 1 by 2. Therefore it becomes F by 2. Means if this angle is 60, then whatever force you are using is actually half utilizing. It's only half of it is utilized here to pull this. This is very important concept, that component. Is that clear? Now let us learn about our vector product, the properties of vector product. Properties of vector product. As like the scalar product, here the first property goes with the definition. What is the definition of cross product? Becomes the first property. That is, the first property is vector A cross vector B gives not this, but the magnitude of this gives A B sin theta. The value equal to the AB sin theta, where A is magnitude, B is magnitude, and theta is the angle between A and B. The second property is if the theta is 0, if the theta is 0, AB 0 is equal to 0, then we can say that self cross product is 0. Self cross product is 0. That means A cross A is equal to A sine 0, that is A into 0, that is whole 0. So self cross product is 0 in all cases. So what about our unit vectors? If you take I cross I, j cross j and k cross k, then it will also be 0 because it is also called as a self cross product of the I. And therefore I can say I cross I and j cross j and k cross k will also become 0. Here in the first part of the definition, we talk about the magnitude of a cross product. Magnitude of the cross product, like the magnitude of the cross product is given by the product of their magnitude and the sine of the angle between them. But what about the direction? Let us write the direction here. So cross product will give the vector which is perpendicular to the plane formed by the two vectors. Suppose these are the two vectors. These are two vectors, and if you join these two vectors, they will form one plane. So this is the plane of these two vectors. Then, if you take the cross product of these two vectors, the resultant vector will be perpendicular. Is that clear? The resultant vector will be perpendicular. So remember, A cross B is a different vector. Vector A, then vector B, and then vector A cross B. Okay, so these are three vectors. Is that clear to you? So A cross B is also a vector, and therefore here I take the mod and got the magnitude of that vector. So this vector will be perpendicular to the plane formed by the AB. So cross product is perpendicular to the plane formed by two vectors. So this is clear that it will be perpendicular to the plane formed by the two vectors. कोई भी two vector, any two vector, they will form one plane, and to that plane the resultant cross product will be perpendicular. But still there is one question unanswered, and that one question is in which direction? It is perpendicular, right? But there are two perpendicular directions. Means if this is the plane, then this is one perpendicular direction and this is another perpendicular direction. So the question is in which direction? So that is answered by the right-handed screw rule. Right-handed screw rule means if you are taking cross product from here to here, means one is vector A and this is vector B. From A to B, vector A cross vector B, A to B. If you are going this way, you are going the clockwise, and if you are rotating the screw clockwise, the screw goes inside. So screw advances, screw goes inside, and that is the direction of the cross product. That means in case you are not doing A to B, you are not doing A cross B, but you are doing B cross A, then screw will come out. So the product will be in this direction, and for this the product will be in this direction. So A cross B is different than the B cross A. So that becomes our next rule, that A cross B is not equal to B cross A. We studied this in case of scalar product, that A dot B, vector A dot vector B is equal to vector B dot vector A. So there they can be shuffled, but here it is not possible. So vector A cross B is not equal to vector B cross A. All other rules are applicable. Okay, and one more property here that we will need to write is to take some mathematical formula, to get the mathematical formula to answer the vector A cross B, not the magnitude. Magnitude is given here. I am interested in finding that vector itself. So let vector A is denoted by AXI, AYJ and AZK. Similarly, suppose vector B is denoted by BXI, BYJ and BZK. Then let us find what will be its cross product. Then vector A cross vector B is equal to AXI, AYJ and AZK cross BXI, BYJ and BZK. Now I will do the algebra similar way, and then I will apply this definition and properties. So first let me do the algebra. Simple algebra will give you A cross B is equal to, first multiply the first term with all these three, then secondly multiply this with all these three. So one by one we will do that. So AX BX I cross I. Remember here, last time I have written I dot I, here I cross I. Then AX BY I cross J. Here AX BZ I cross K plus, then now AY BX J cross I plus AY BY J cross J and then AY BZ J cross K. Again AJ BX K cross I plus AZ BY K cross J plus AZ BZ K cross K. Now let us apply the properties. Here A cross B is not equal to B cross A. A cross B is not equal to B cross A. That means this JI will not be equal to IJ. JI is not equal to IJ. Is that clear to you? And also I cross I, J cross J and K cross K become 0. So these terms become 0. So in next line I will not write about them. Next line we will have only 1, 2, 3, 4, 5 and 6 terms. There will be only 6 terms in next term. Okay. One more thing to notice here is that if I write here I, J and K and call it a cycle, or instead I will write like this I, j and k. If you go from I to j, you will get the positive k. If you follow this, then you are getting the positive value, because here cross product is perpendicular to the plane formed by the two vectors. That means if I take I into I cross j, then I will get the direction k. If I take the j cross k, I will get the direction I, because they are mutually perpendicular. But in reverse order, I will get minus of the k. If I write j cross I, then minus of the k. If you are going reverse, you are getting the third value negative. Okay. So in that case, ijk, keep in mind the ijk. So I cross j is k, but the j cross I is minus k. Is that clear? So we will repeat that everywhere. I to j is a clockwise direction, so it is positive. So ax by I to j is k. Is that clear? And the second is ax bz I to k. You are getting I to k opposite anti-clockwise, then minus of the j. So it will be minus of j. Then what about this? Then you are getting a1 bx j to I. If you are going j to I, you are going opposite, then minus of the k. Minus of k. Then for this, for this, a1 bz j to k. J to k is a positive clockwise direction, so positive I. Then for this az bx k to I, you are going k to I, you are going clockwise, so j is positive. J is positive plus az by k to j is reverse, so minus I. Okay. Now here I will arrange the I, j and k. I will arrange I, j, k and keep the first positive, then negative, then positive order. Okay. And I have to arrange first I, then j and then k. So first I will arrange I, and I will be positive. So I. So this is positive. So I will write ay bz minus, again there is one I, which is negative, aj by, and then I will use I. Now negative. Next is compulsory negative. So negative and j. So for the negative j, I will need negative first. Ax bz, negative of the j. Then positive of the j, this. So this is minus az bx and j. This is minus because this minus is coming here and making it positive again. Okay. So then again plus. Then I will use k. For the k I will use positive first. Ax by minus, then where is minus k, this a1 bx, and here you will get k. If you will see this structure, you will find it is equivalent to the determinant I, j, k, ax, ay, az, bx, by, bz. Is that clear to you? So cross product of two vectors can be obtained by the determinant, where I, j, k will be the first row. In a second row, you will write the coefficient of the second vector and the coefficient of the first vector, and in the third row, you will write the coefficient of second vector. So this is how the mathematical formula can be obtained. So this is the property also. Now see what this property, this AB sin theta gives us. In fact, when we take the cross product of the two vectors, what exactly we are getting? Suppose you are having a triangle formed by the two vectors, vector A and vector B. The triangle formed by the two vectors, vector A and vector B, and suppose this is the angle theta. So we are here to understand the geometrical meaning of this. So if the two vectors form the triangle, then the area of the triangle is equal to 1 by 2 into base into height, as you all know, isn't it? This is the area of the triangle. Let us find the area. This side is equal to A, this side is equal to B. So B is base into base, and write like this, base. What is this? Height. If this is h, then you can write sin theta. Sin theta is equal to opposite upon hypotenuse. This hypotenuse. This is 90 degree. So what you are getting as a h? H is A sin theta. You can write here A sin theta. Okay. So BA sin theta is what? This is 1 by 2 AB sin theta. BA sin theta is what? A cross B. A cross B. Now you see, area of a triangle is represented by half of the magnitude of the cross product of the two vectors. ये दो वेक्टर वही है which form two sides of the given triangle. So that is the cross product of the two vectors gives the area vector. So we can infer here that the cross product of two vectors gives area vector. But keep this in mind. In next chapters, we will study about the electrostatic, current electricity. Then we will need this concept of area vector. So this is the geometrical meaning of area vector product. Is that clear to you? So here we finish the today's syllabus. Now next lecture will be about the JEE and NEET related question based upon this vector. So have a good day.